Coming up on Destination Tomorrow, we take a look at a new technology called the Small Aircraft Transportation System, or SATS. We'll see how this program will revolutionize air travel as we know it, and we'll visit its historic rollout event in Danville, Virginia. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steve McGonigal.
And I'm Kara O'Brien. Welcome to this edition of Destination Tomorrow.
On this episode, we'll be focusing on the Small Aircraft Transportation System, or SATS.
Throughout NASA's history, its researchers have developed cutting-edge aeronautical systems for use in commercial, military, and general aviation aircraft. Although much of the spotlight goes to commercial and military aircraft, general aviation has greatly benefited by the work done at NASA. One of the most recent programs that helps promote and bring these smaller aircraft to the forefront is the SATS program.
The thought behind SATS is simple. Reduce the congestion and safety problems of our highways and airways by using small aircraft as a travel alternative. As anyone who lives in a large city can attest, our highway systems are frequently plagued with traffic jams and accidents, while the nation's 30 major airports are overwhelmed with increased flights, frequent delays, and flight cancellations. If SATS is implemented, the result will be a more distributed air transportation system that will use thousands of underutilized airports throughout the nation. Its focus is to prove that small aircraft can enable safe and affordable access to virtually any runway in the nation in most weather conditions. SATS will offer on-demand, point-to-point, widely distributed transportation systems by relying on advanced 4 to 10 passenger aircraft that use new, state-of-the-art operating capabilities. Such a system promises improved safety, efficiency, reliability, and affordability for small aircraft operating within the nation's public use landing facilities.
SATS is a partnership among various organizations, including NASA, the FAA, the U.S. aviation industry, state and local officials, and universities. The United States Congress funded the program with $9 million for fiscal year 2001 and budgeted $69 million for a 5-year proof of concept period. If implemented, SATS will reduce transportation times to more communities by half in 10 years and by 2/3 in 25 years. Starting in 2001, NASA and its partners were given 5 years to prove that SATS could increase high-volume operations at airports without control towers or terminal radar facilities, devise technologies enabling safe landings at more airports in almost all weather conditions, integrate SATS aircraft into a higher capacity air traffic control system, and improve single pilot ability to function in the national airspace.
The culmination of these efforts were highlighted at the SATS rollout event in Danville, Virginia. To help us understand how SATS may change all of our lives, Tonya St. Romain attended the SATS event and had the opportunity to speak to some of the key players.
If you ask almost any air traveler what they think of the current air system, you might hear some grumbling. Although the current aviation system is very effective, it's beginning to reach its limits. Currently, long lines, frequent delays, and crowded skies are bringing the current aviation system to the brink. And with an estimated 1 billion passengers flying by the year 2014, increased environmental constraints, and new security threats, change needs to be made now to reverse this downward spin. But what can be done to help? Well, today we're out here in Danville, Virginia for the historic rollout of the Small Aircraft Transportation System, or SATS. This new system could take a lot of the headaches out of flying. NASA, along with the FAA and the aviation industry, have teamed up and are out here demonstrating these new aircraft systems and how the technologies inside this aircraft could revolutionize flight as we know it.
SATS is basically a vision, okay? And that vision is a new way to provide transportation using small airports for people to go and come when they want to. What is a major part of that is the use of the small airplanes. There's a whole new generation of small jets and advanced general aviation aircraft that have technologies that are being developed that make them easier to fly and make them more reliable. And using those, you can fly from your neighborhood airport. What this would mean is that you want to go visit grandma. You go to your neighborhood airport. Maybe she lives 600 miles away. You never went through a hub or a spoke. You never changed planes. You never went through all of the frustrations and difficulties that you have today on whether your flight's going to go cancel or this type of thing. I think the analogy for SATS today goes back to many years ago where trains took people from city to city. And if you wanted to go to those cities, the train was very good. It worked real well. If you wanted to go places that the trains didn't go, once you got to the city, you had to find some sort of transportation to get you where you wanted to go. Maybe it was horseback, maybe it was wagons, this type of thing. And to meet the need to go where people want to go, automobiles were invented. Today, I think that the airlines are like the trains were many years ago, and they don't take people to where they want to go. So you need some sort of means to go to communities that the commercial airplanes don't go. SATS is sort of like the cars. It's the beginning of the movement to take people point to point from where they live to where they want to go, instead of going to places that you don't want to go to get to places that you do, which is the best way to describe commercial air today. It's a very efficient system. It works well. It's very crowded. It's a wonderful way of transportation, but it doesn't take people where they want to go, when they want to go. It doesn't consider the value of an individual's time. SATS is about time. It's about using your time wisely and doing it in a affordably and safe manner.
The way the technology plan came together was, we got a group of really smart folks together, sat around the table actually for almost a year, trying to work our way through, how is it that the technologies lead to the ability to operate in the airspace in ways you cannot operate today effectively, affordably, safely? And how might those technologies enable an industry to do things they can't do now? And so we looked at the fact that about 98% of the nation's population lives within about a 30-minute drive of an airport like Danville, Virginia, or like the one I live near in Williamsburg, Virginia. Except that those airports don't have the navigation aids and the communication capabilities that are necessary if you want to have truly reliable access in the air. And so how might you put the technology in the aircraft instead of on the ground? And that's the question we started with, and then that led to the ideas of what we call higher volume operations at airports that don't have towers, don't have instrument landing systems, don't have radar, don't have voice communications. And yet if you just simply put this capability in the aircraft, when the aircraft arrives, it brings everything it needs. Well, what a concept, we thought. And so that became one of the drivers behind moving this idea forward. And then we looked at, well, what about operating up and away in the altitudes en route with everyone else? How do we stay out of everybody's way? So we looked at technologies that can help with that as well. And then we spent some time trying to understand the economics and how it plays out in people's lives.
Currently in the U.S., there are about 3,400 small community airports which are being underutilized. Most of these airports are so small, they don't even have a radar or towers to control aircraft. The SATS program has developed technologies that would allow us to finally begin to utilize these airports to their full potential. This new system will allow new classes of aircraft, including very light jets and other advanced small planes, to use these neighborhood airports to fly people from place to place rather than relying solely on the hub and spoke airport model of today. That means a family will be able to go to their community airport, take a plane to grandma's neighborhood airport 600 miles away, and never have to go through a major hub or change planes. And with most Americans living within a convenient 30-minute drive from one of these small community airfields, the SATS program will prove to be a perfect fit.
One reason the airport in Danville was chosen for the rollout was its size and relative proximity to cities like Washington, D.C. and Raleigh, North Carolina. Later, we'll head back to Tonya at the expo, but first,
did you know that per capita, Alaska has 6 times as many pilots as anywhere else in the United States? Alaska encompasses more than 500,000 square miles of land, which includes glaciers, mountains, and tundra, which are largely inaccessible by vehicle or boat. Many pilots in Alaska are called bush pilots, which refer to the remote and mostly remote areas of Alaska called the bush. In fact, piloting is so prevalent that 1 out of every 64 residents has a pilot's license.
During the 5-year proof of concept period for SATS, a great deal of technology was developed and tested. Today, many manufacturers are taking much of this technology and implementing it into newer models of their aircraft, and are even designing new types of very light jets, thanks to the groundwork provided by NASA and its partners. Well, let's rejoin Tonya in Danville to find out more about some of this new technology.
Now, many of the technology areas that you see here were developed by industry, by the SATS labs. But NASA typically works with the people in industry to develop technologies if we don't do the research that comes up with new technologies. The FAA is basically the people that manage or oversee or regulate operations. So they're working with us and they help us to understand how technologies are going to be deployed, what is the impact with regard to the operation of the FAA. They help us make sure that they're usable and useful, okay? And then you have the private sector. They're the ones that take technologies and turn them into products. And so you got everybody coming together to make this happen. It makes sense. Brings it to the market and you end up with a product that's usable, one that people are looking forward to using.
The feedback has been very, very positive. We're able to actually do SATS type of operations with some of today's modern propeller airplanes. Some markets are such that you really don't want to go that far and you don't need to travel that long, but it can take a 4 or 5 hour automobile trip into about a 30-minute trip in a light propeller-driven airplane that's a very modern airplane. These airplanes are equipped with technologies that didn't exist 10 years ago. Everything from parachutes to in-flight information systems that provide the pilot a lot of safety.
Coming up, we'll find out about some safety devices now being built into small aircraft. But first, did you know that a device nicknamed the chicken gun is used to evaluate bird strikes against aircraft? Although birds seem harmless in the air, they can prove to be devastating for an aircraft if they are ingested into the engine or strike a windshield. In fact, since 1912, at least 300 people have been killed since the first fatality was reported due to bird strikes. To help validate and develop testing on aircraft canopies and windshields, the relatively low-tech chicken gun, located at Arnold Air Force Base, uses high-pressure air to fire chicken carcasses directly at aircraft. The chicken is fired from a 60-foot-long launch tube at speeds exceeding 900 miles per hour to simulate a direct bird strike. This data is used to determine the ability of the aircraft to withstand the impact and the damage caused during the strike. This technology has been used to improve designs and materials to make aircraft safer. This facility also helped support NASA's Space Shuttle Return to Flight program by launching hundreds of foam projectiles made of materials used on the shuttle's external tank. These shots simulate pieces of external tank foam breaking away from the tank during flight and striking various parts of the space shuttle, such as the solid rocket booster.
One of the key factors that will encourage members of the general public to use the SAT system will be safety. Currently, there are well over 250,000 active general aviation airplanes around the world. Unfortunately, about 1 in every 300 of these planes are involved in an accident every year. To make general aviation flying safer, NASA has funded an innovative new parachute recovery system which, when deployed, may actually allow pilots to walk away from what could have been a catastrophic accident. With systems like this aboard, flying will become much safer. Here's Tonya to explain.
The sight of small aircraft flying around our skies is a familiar one to most of us. These small general aviation, or GA planes, are favorites of private pilots, small businesses, and flight schools because of their relative low cost and the freedom they provide. Although these aircraft are very safe, about 1,600 of them are involved in accidents every year, and quite often, these accidents can be fatal. In an effort to prevent many of these accidents from becoming fatal, NASA has funded an innovative program which uses a ballistic parachute mounted on the plane, which when deployed can actually save the plane and the passengers from a catastrophic accident. I spoke with Lisa Jones at NASA Langley Research Center to find out more.
Parachute recovery systems are not new. They've been used to return our astronauts from the moon, the Apollo program for instance. They've been applied to the military aircraft such as the F-11 Crew Escape Module. It floats down on a parachute recovery system. Now they're being applied to general aviation aircraft. And in the structural designs, this is a good way to save money and weight because you can actually design a structure to support the parachute system.
The parachute works like this. During an emergency event, if the pilot feels that he's about to lose control of the aircraft or has lost control, he must turn off the engine, then simply pull firmly on the parachute release handle located above his head. The parachute, which is propelled by a solid fuel rocket motor, is released from a special opening on top of the fuselage. 3 Kevlar straps connect the parachute to the airframe and help slow the aircraft, guiding it through a level descent. Although the parachute system already has 155 saves with ultralight aircraft, the first save in a general aviation plane came in October of 2002, with the aircraft suffering little damage and the pilot walking away from the crash with no injuries at all. So Lisa, is this parachute system just for new aircraft, or can it be retrofitted on older planes?
Parachute system design can be incorporated into older aircraft designs. It's just you would have to do some modification to the structure, make sure that the structure could handle the loads the system puts on the airframe, and also be certified for it.
Lisa, what are some situations where a pilot would need to use this device?
As a pilot can tell you, there's many times when things would go bad quickly when flying. So there are many different scenarios where this system may be deployed.
Some situations where a parachute recovery system could be used are loss of control of the aircraft due to icing, engine failure, and airframe structural failure. One of the most common causes of general aviation aircraft accidents is pilot disorientation. Many pilots are only rated to operate an aircraft under visual flight rules, or VFR. But in order to fly in bad weather, a pilot should also be able to fly under IFR, or instrument flight rules. If a visual flight rules rated pilot encounters weather where he can't see visual landmarks outside the plane, then spatial disorientation can occur. When this happens, the pilot literally cannot determine if his plane's in level flight or if it's turning or banking. Very frequently, the VFR pilot will rely on his instincts rather than his instruments, which can lead to a catastrophic outcome. With the parachute recovery system on board, no matter what the situation, the pilot has one last best option to save not only the aircraft, but most importantly, the lives of everyone on board. I know this is being used for general aviation aircraft, but is there a chance that it could be used on larger planes?
I think it can be applied to some of the business jets where you're talking about 10, 12, 14 passenger perhaps. That would have to be really investigated closely. But for application to a transport, you're not going to see that. The structural requirements for the aircraft would be enormous to handle that, as well as the design characteristics for the chute itself to be able to take the energy of a large transport. So you're not going to be able to use this efficiently on anything of much size greater than a general aviation aircraft.
So Lisa, why is NASA working on this type of project?
NASA has a program called the Aviation Safety Program. And in that, we're looking at different types of things to improve safety everywhere. Some of that in the early part of the program was focused on general aviation. There are 1,000 lives a year lost to general aviation accidents. And this type of system can really improve